address, what you can do is you can just move a static memory address into a register and copy the data at that memory address. Now you know what it's going to be every single time, but the dynamic translator is dumb. It doesn't understand anything about operating systems. It doesn't know anything about common memory space layouts. So what this can be done, or what this can do, is it can essentially just bypass dynamic translators because they're too dumb to know anything about the memory space layout. Let's skip better exploit side technique for now. Using instructor-specific or obscure instructions may be useful for breaking dynamic translators temporarily. Dynamic translators are going to understand the basic instructions. They're going to understand XOR. They're going to understand move. They're not going to understand, instructor-specific instructions or instructor-specific instruction sets like 3D Now, which is on AMDs but not Pentiums, or SSE2 or MMX or other, uncommon instructor-specific instruction sets. So this is a fairly weak approach. It can be pretty easily bypassed by just adding some new instructions. But if you're in a bind, this may be something to look at by, writing MMX polymorphic shellcode encoders. How much time do I have? I'm fine. All right. All right. Well, does anyone have any questions before? I mean, I can cover some other things here. I'll take some questions. I'd rather take questions.
Quick question about the smart sticks. Have you actually performed those in a production environment with a lot of traffic? If so, what was the false positive for?
No, I haven't. I don't own one of those types of networks. The only thing, supposedly, no. No, I haven't. I'm not the type of person who is at that level. And in fact, I will tell you that the speed hit will be significant. I can tell you that the false positive rate will be pretty low, but the speed hit may be significant. I mean, the thing about shellcode is that you need to run it on all ports, or at least that's the default setting. But I mean, if you're like running a server and inbound port 80 is like a Apache and inbound port 25 is like a SendMail, you'd be better off just running the shellcode just on SendMail, because that gets owned every 2 months, while it's pretty stable. So you can be sort of smart in your filtering, and that can also just help reduce the speed hit of using these signatures. But I mean, I think the real key here would be to actually build a scoring system, or build some sort of I forget what the name is exactly, but there is some sort of snort feature where if one signature says, yes, the signature just happened in some packet, then another signature activates for that stream. So it's just if this, some NOPs happen, like the shellcode or something like that. But if you want to get into it, you can make this considerably faster.
The Chicago 9 for version 3 is slightly weaker than version 2. Can you elaborate on that a little?
I did all this research about half a year ago. Basically, a couple of the dependencies are sort of screwed up. For example, if you look here, it says clear ECX and then mov Zorlin. So it should be able to occur in any random order. You can have clear ECX and then FPU ints and a bunch of stuff and then mov Zorlin. Well, one thing is that clear ECX occurs and then mov Zorlin occurs every single time. It always occurs in that same order. So I guess one of the dependency structures was just screwed up in the version 3. And if you look at the PCREs, they're also slightly different. The shellcode.rules files included the code.tgz file. So you can check that out for yourself. But I forget the exact differences.
Host side, so doing for you, doing your factor, are you doing like this host side, or are you actually doing some wire?
I'm just doing it host side. I basically just generate a bunch of encoders on the host using the MSF encode utility, which is included in the Metasploit framework. I just create a bunch of different ones, and I just dump it into a file with a specific file format, and then Spectrum or Spectrum.c can understand that and look at it and tell.
What level of success are you having right now as far as for the stuff that you're generating?
What percent of Chicago 9 coders is caught by this? 100%. Yes. Spectrum analysis itself could be used for getting slightly fuzzier fingerprints, but slightly faster, if you're familiar with that. But I wasn't into the whole fuzzy thing. I always wanted 100% or nothing, so I built it like that.
So for all kinds of purposes, version 2 is actually
Yeah. It's just, yeah. Should I get off or? All right. That's it, folks. Thanks for coming by. If anyone wants to complain at me for talking too fast or look at some of the slides I didn't cover, I'll probably be outside for around half an hour or, well, probably for like 10 minutes if you want to bug me for a while.
Listen, if you do want to build a high-traffic network,
Joe, I'm your call for paper.
On the what?
Your call for paper?
Oh, thanks, dude.
Well, it's fun little reversing thing, you know.
Yeah. If you look at it, it's actually a lot simpler than
Yeah, I know.
Yeah,
I
it's
actually after I looked at all the code, I was like,
yeah. That's just the common, and it's a bunch of go-tos, and it basically
right.
does nothing, but
what
it
was
looks
funny
nice.
Is that I wish I would have done just like a basic statistical analysis, like on because you had so many of the same things. Like, oh,
Yeah.
here, that's a space.
Yeah.
That's a this.
Yeah, it was not meant for
Cryptographic,
cryptographic,
think outside the box. Yeah.
Yeah.
Good talk though.
Are you gonna post Spectrum for like your Spectrum?
It's on here if you want it.
I didn't bring anything on.
If you want, you can email me at my address. It should be
Does Vinny have a copy? Or
Vinny who? You know, do I know you by chance?
maybe.
I know Vinny.
Yeah.
Yeah. I mean, if you want, just tell Vinny and I'll drop you a line or something. But
I was supposed to roll down here with Vinny and Patrick, but they because of work things.
yeah. But I mean, if you want, just email me or tell Vinny, and he knows where to find me. Cool.
All right, that'll work. Thanks, man.
yeah, later on, after the common roll, when we're back in the Toorcon, we'll settle down if you really want to do some performance testing.
Too much work. Sorry.
No, I'll take it over. I'll do it.
Hey, if you want to do it, man, the code's out there. Stuff happens.
You got a radio with the guy.
Yeah, it's fine.
It's Vlad 902.
Yeah, Vlad 902. Yeah.
Cool, thanks.
Sorry about time.
What is your topic? Oh, yeah. Okay. No problem.
Have you seen the curry?
Huh?
Have you seen the curry?
No, I haven't.
Okay. Generally, he was introduced on this round, so I don't know if there's any if he's back yet or not. If there's any issue.
No, there wasn't. I just said my little spiel.
Okay.
I think he went out to Sips, and right, he came back, but the rest stayed back to get some takeout for the rest.
Cool.
Yeah, I started out a bit late, so I got this. It was alright. I skipped one thing, which I basically said in my slides, you can do this, but I didn't because bite jump sucks. And the other thing was, you can do this, but it's too slow. So I just skipped the sort of things that are theoretical, but